Hi everyone. Today we are going to look at the regular expressions. This is IASB 445. As you can see on your Blackboard, there are multiple postings available. First of all, lecture notes, and then cheat sheets for regular expression. And then there is a IPYNB notebook, Python notebook files. So I'm going to give a lecture short, very quickly. Point out some significant points only to you guys so that you can read it and get some understands. And also practice on this Python notebook. And then later I'm going to post here the recordings. Right now I'm recording, right? So if this recording is done, then that will be on these items. Based upon this notebook and the Java note, Python notebook and then lecture notes, there will be a homework assignments. All right, so let's try to do the lecture notes. So this lecture notes start with the definition of a regular expression. What is a regular expression? In Python, regular expression is called RE. So RE is a Python module. So if you want to use regular expression, then you need to import RE. RE is a powerful tool in Python, searching, matching, manipulating text-based specific patterns. Okay. So the regular expression automates text processing tasks that would otherwise require complex loops and conditions. But because we have RE modules available in Python, you don't have to worry about all details implementation, but simply use it. How to use, that is on our Python notebooks. So there we can validate the inputs, finding patterns and replace patterns and splitting strings and more possible. And then cheat sheets are available that also posted on the Blackboard, which is this. Okay, so in order to express regular expression so that you do not have to express all possible instances, all possible examples, but you can describe, for example, some of the regular expression. Let me give you an example. The email address. If you want to find out email address from a large volume of text, electronic text, then manually you can find it, of course, but it takes so long. So anyway, what would be the pattern of email address. The pattern needs to be expressed in a simple way so that if anything complies with that pattern, then we can simply see, oh, this is a email address. Likely a phone number. Then we know what is the phone number, right? Usually, if it is written in the traditional format, then open parentheses and 3 digits and close parentheses followed by 3 digits, dash, and then 4 digit numbers. Then we see that is the email address. What about URL? What is the name of the universities? What is the name of countries? What would be name of, for example, wines? What would be the example of you name it? There are so many patterns. When we form the name, then it follows some patterns. So if we know the patterns, then we can express it in formal way. That's a general forms. Okay, we don't need to worry about all instances, examples. So in order to express it, some language here. This is called, I'm not sure how you call this. This is symbol, up arrow symbols. There's a starting string, and if we have a backslash and something, then there's a start a string, and dollar sign end of a string. So start of a string, you simply say it is it the carrot? I think it is. There's a carrot, right? Carrot. That is the start of a string. This is a well known, and then dollar sign. That is the end of strings, and there is also the class of character classes. If you want to see the control character, then \C, Control S, then white space, Control uppercase S, not no white space. \D means there's a digit. Uppercase D, then is not a digit. \W, word, and things like that. And then this is a POSIX. Some other cases you may use in this POSIX language. And star means that is a quantifier, the number of occurrence. Star means 0 or more occurrence. Plus sign means 1 or more occurrence. Question mark, 0 or 1 occurrence. Or you can do within the curly braces, one number, then exactly 3 times of occurrence. And then if there are 2 numbers, then first number is the minimum, and the second number is the maximum. If maximum is empty, then it would be simply more, infinite. And then 2 numbers with the comma delimiter, then that is between 3 and 5. That's a quantifier. All right, that is an escape character, \. That escape character is very common in programming languages, right? And then there is a meta characters. If you want to get these characters, for example, carrot, then you need to have a \. If we want to express not the control character, but a character itself, for example, dollar, then you need to do $. Why $? Because dollar is already defined. That is end of a string, right? Dollar sign means end of a string. Carrot, that's a starting of a string. If you want to literally express carrot or dollar, then you need to have a \. And parentheses, and then brackets, and less than greater than sign, and the star plus questions. Star plus question we already looked at. If we say star, then that is a quantifier. But if you want to express a star itself, then you need to say escape character \star. Then it doesn't try to understand what star means. Rather, it simply see, oh, that is the literally star. Okay, that's what it is. Some special characters, \n means a new line, \r, that is a carriage return, \t, that's a tab, backslash V, that is a vertical tab, backslash F, form feed, backslash XXX, octal character, backslash XHH, hexa character. Okay, there's assertions, question mark equal, then look ahead assertion, question mark and the exclamation mark. There's negations, and so on and so forth. And then there is some group of ranges can be specified within the parenthesis. If you have A or B or C, then you need to have a vertical bar. A vertical bar, B vertical bar, C, all together within parenthesis. Then they are grouped, and what it means is that A or B or C. Okay, so parenthesis is a symbol for grouping. Square bracket means the range. So A or B or C. It is for example, A dash Q within square bracket, then that is A or B or C, A through Q. That's what it means. Uppercase A through Z, then all the uppercase characters, if it is within square brackets. Okay. So a little different. This is a square bracket, and this is a parenthesis. In parenthesis, then it'll pick one or the other. Square brackets, anyone in between. So square bracket 0-7, then any digit between 0 and 7. And then so for example, sample patterns, parenthesis here all together. So that is a group, right? And then there is a square bracket and plus. Anything in square bracket can occur. Plus means one or more times. So anything in between, A through Z, uppercase, A through Z, lowercase, 0 to 9, and the minus sign. Okay? Any of this that takes place more than one time. So this means any character, any letter, any number, any hyphen, which is minus number, can appear continually. Okay? So any characters that can be written in this way. If you want to see, for example, this is I think March 21st, 2006. If you want to express it this way, then remember that it's a slash. First of all, 21. If you want to say 21, then all together is a group. As a group, there's a backslash D. Backslash D means that is a digit, right? Any digit. I want to express a digit, and the curly brace. Digit takes place minimum 1, maximum 2. Okay, one digit or 2 digits. So it could be 99 also, although that is not the date, but 99. And then there's a backslash and slash. If you want to express a slash is a special character, meta character. If you want to express a slash, then you need to have escape character. That way you can say slash. I think it should be slash somewhere here. This is backslash and slash. If you want to do literally slash, then you need to have a backslash and slash. So slash appears here. And then another digits. How many? Maximum one single digit or two single digits? Two digits that appears. That can say backslash D within curly braces, which means if we say curly braces, then that is a quantifier, right? As you can see here. So one single digit or two digits. And then another slash, and then 4-digit numbers. So it could be 99/99/9999. That is also possible based upon this, the regular expression. Another regular expression, everything from the to the end, that is a group. The first thing here is a square bracket and then plus sign. Plus sign means that appears, that takes place one or more times. And then there is a caret, which means it start. So caret means start. Followed by, it start what? Start slash s. Slash s means then slash lower s, slash lower s. It's a white space. So it could be, it starts with a white space, any time of white space. And then question mark equal means look ahead assertion. Where are we? Oh, here. So question mark is, and then backslash dot. So we could have a dot, okay? And then another group, JPG, vertical bar, GIF, vertical bar, PNG, and close parenthesis, which means either .jpg or .gif, .png. Okay, so it looks like a file type. And then there's another dot, and then backslash 2, backslash 2, simply a number, backslash, there's an escape character, backslash is escape character, but backslash n is a group and sub, nth group. Backslash 2 means nth group here, right? So second group. Anyway, that is JPG, GIF, PNG files. And then the other one is you start with the number between 1 and 9, any number between 1 and 9. And then 1 and 9 takes place only one time. And then dollar, and vertical bar, any number from 1 to 50. So it ends with 50 caret. All right, this is two difficult ones. So anyway, this kind of things is a the regular expression. The regular expression, there's a literal characters that we could see, and special character, backslash D, that is for the digits, backslash W, that is a word character. There is a quantifiers, how many times it takes place, like that. And anchor, specify position in the string. If we have a character, then it matches the start of the string. Dollar matches end of the string. Okay, that we looked at already from the cheat sheets. All this very so regular expression is a little bit complicated automata based on automata theory. But these things is not only in theory, but already implemented in Python. So you simply call. So there are the functions available: search, match, find all, sub, split. For example, if you want to scan a string for a match and return the first match, then you can do search. If we want to find all matches, then you need to use find all. Search returns only the first match. If you say match, then check if the beginning of the string matches the pattern. Okay, so that is if the beginning of the strings matches. Sub, it replaces the matches in the string in a specified replacement. Split, string by the occurrence of the patterns, so we can split the patterns. So we look at the hands-on. So hands-on is on the Google Colab. Okay, so I'm going to close this and push this away, and then I already have what you need to do is that you need to if you click this, then it can be downloaded on your laptop, right? So if you click in download, then you can see that file, right? And then that file needs to be loaded. So I already loaded that files. So from the top, and you can read and practice. And I describe some of the examples. So using re.match, re.search, re.findAll, sub, split. We can practice all of those here. So what you need to do is, as I put here, first trying to match as simple patterns. In order to do that, you have to import re for regular expression. And let's say I have a text and pattern. From this text, I want to see the matches. Hello. Hello is in this regular expression, R. So I can run re.match, then pattern from the text to see if hello is matched. Okay. If this text starts with a hello, okay, then it can returns. So, and then the if match, so it returns true or false. If this is true, then we can say match found. If it is not, then we can say no match. If it is matched, then we can match the the group, so we can, this guy know what pattern has been matched. So by clicking this, matched found. So which one's matched? Hello. That's what it is, right? For example, if we say Mercy, hello, then it is not matched because this text doesn't start with the hello. Okay, only it matches to see if it starts with the hello. Then we can use this match functions. Then we found the matches. The other one is a search. From this text, I want to find out in regular expression. Of course, I can do, for example, here pattern equals jyoon at cyber.edu.com. Then it found email at academia found. That one is found, right? But if I have not only this, I have many others. So can I get them all? In order to do that, then you need to have a regular expression. So what is the pattern of the email expression? Then you can say, if it is academia, then it ends with .edu, right? And in between there is @, and then strings, how many times? One or more times. And start with the string, how many times? One or more. As far as this matched, then it can return. So it returns. So search means it gives me the first match, right? So first match, this is not matched because it is .com. This is matched, right? jyoonmercy.edu. Because it ends with the .edu here, and then strings, some strings, and then @. That's what it is, right? But for example, to yoon at mercy.edu. Let's say this looks like an email address, right? But see if it fits to this regular expression. Hit enter. Then \h means if as far as it is not white space, then it returns, right? As far as it is not white space. So this is not white space. Therefore, the first match will be to yoon at mercy.edu. Find all. If you want to find all, search gives you the first match. Find all, it returns all the matches. Let's say this is a text and pattern here \d plus. Plus means there is occurrence. It takes one or more times. Minus small d means digit, right? If it has any digits, single digit, double digit, and triple digits. So anything it happens, then you can see here, it has 10, 20. From this text, for example, 301, it returns that also. 10, 20, 301. And then substitute. If you want to substitute, it can do. In this text, cats grades, substitute this pattern. If this pattern is found from that text, then we put it, instead of cats, we put that dogs. Okay? And then case is ignored. So we have cats here, and there's uppercase cats. So ignore that. We simply plug as a dog. So if we do that, then it's I love dogs are great. Instead of this cat, instead of that uppercase cats, because we said ignore, but we replace it. Splits. In this statements here, apple, comma, banana, semicolon, orange, vertical bar, and the grape. If I want to split this text based upon colon, semicolon, vertical bar, then we can say they are fruits. Apple, banana, orange, grapes. If I remove vertical bar, then they will go together. Apple, banana, but orange and apple in one word, because I didn't say that here, right? So when I split, then that pattern needs to be in this regular expression. Remember this square bracket, then it gives me anything in this range, comma, semicolon, and vertical bar. What else can I do? Maybe dash, so that if I say blue moon, if I do this, then blue moon, because I included this hyphen based upon hyphen, this word can be split, right? Blue and moon. We can also make a group. If we have a pattern, say this is a backslash, open parenthesis means there should be parenthesis, literally parenthesis, because this is escape and parenthesis. So literally parenthesis, start with the parenthesis. And then here is another, and with the parenthesis. Within this parenthesis, I have here group. Okay. Backslash D means there's a digit. How many digits? We have a plus sign means 0 or more digits. Okay, we have 0 or more digits. Those are the number, right? So for example, if I have here possible, right? Because it didn't say how many, but 0 or more. So we have a close parenthesis, and after that, another group. In that group, also number of digits, hyphen, and number of digits. So those are all the phone numbers that we can see here. Area code, that many, right? Because we didn't do anything here. But if we say that pattern a little more, oh, this is good. I want to make a digit 3 times, area code 3 times. And then prefix number is 3 times, 3 digits, dash 4-digit number. Then this will be excluded, right? So only the next 2 numbers can be matched. So area code 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That is what that means. Because we said here search, right? Search means the first match will be listed, right? If we say find all, then it returns find all. If we use find all, then what you need to do is simply find all and then return that. So if we want to do more, then we can do, for example, print re dot find all, and here pattern, comma, text. Hit returns. Then, because these two are typical phone number, the first one is not phone number, so those two numbers are returned based upon this. Compile, pre-compiles a regular expression to improve the performance when we have that. If we want to do this pattern, I want to make it compile first. This is for the performance improvement. Other than that, it check as is Python. Multiple choice is a find all, with that we already know. And look ahead. For example, here, patterns, question mark equal 3. Python followed by, within that parenthesis, question equal 3. That is this look ahead assertion. So I want to see if it has a number 3. I want to get, I love a Python 3, but not Python 2. Find all. If I say question mark equal 3, then it returns Python only, right? Patterns. So pattern is Python. So Python matches, because I said equal 3. Look ahead. So 3, 1 there. If I say 4, then there is no Python 4 here, right? If I say Python 2, then there's still Python, because it is matched from that Python. Or yeah. Oh, okay. Negative ahead. So not Python 2, only Python. Then question mark here, negative look ahead. So 2, then still Python. It doesn't mean that Python 2. It means because there is a Python 3, then we can say Python 2. But if I say Python 2.3, text is Python 2.3, then 2 and 2, therefore we have 2 Pythons, right? Because I have Python 2.3 and Python 2. 2 times of a Python. For this text, if I say, I don't like 2, is there any matches? If I do this, nothing can be matched, right? Because they are something about 2. Case sensitive, case ignored, that we looked at already, right? Ignored. And homework number 1, write a Python script, the requirements, use the regular expression module to find all email address in the text. On email should be follow patterns. So start with the letters, numbers, dots, underscore, hyphen, contains at symbols, end with domain name, the top level domain name, which is .com, .edu, .org, .net, something like that. So from this, if this is the text, your program needs to return from this, extract emails, test.email.gmail.com, support. So it says, oh, this is an email. Oh, this is an email. And this is also email. And user at gmail.com, oh, this is not email. And someone at .com, this is not email. So only the others can return. So this is a regular expression. So your code comes here. And homework number 2 is also similar about the URL. What you need to do, your the homeworks. See, this is .pynb, and homework here. If you click this, then it says lecture. Please review lecture notes, and then cheat sheet that we already looked at, and the recording by practicing the codes. So I want you to practice the way that I show to you, and then coding on 3py 3.ipynb. So I want you to upload. Go back. To put here. I want you to download. Yeah, I need to put here. Upload. Right, this should be up here. So download this, then you will see that file here. That file should be loaded. I believe I loaded. Yeah, I think I loaded here. Right? Reconnect. So I loaded that. So this is the file already. There are 2 problem sets, problem number 1 and problem number 2. And your code should be here, right? So if you come here, you need to use this. This is something like this is a pattern. Let's say this is a pattern. I'm not going to give you all, but let's say this is a pattern. You need to do import RE, and then pattern equals the one that I already shown, and then text equals from that. I believe this is the text. Okay, so back here, within that I can do like this. You can make this one. Yeah. So we have text and pattern, and then find all, right? So somewhere here, yeah, you can do this match, find all, back here, and then match and find all, and let's run. Then it says problem number 1, and this is found, right? What is invalid? I think that is somewhere. I'll show that here. Admin. Oh, this is all together. Why I have this? So these 3 can be found. Okay, so you work like this, and then what you need to do is, I want you to download this as a .py files, and this .py files, and make sure this .py files is pure Python files. And if you are not know for sure, then you don't need to put this. This can be deleted, and all others looks okay for your Python, and you can submit this. All right, like this. From this points, as far as your Python code is valid in Google Colab, then you can work like this, okay? So there is the worksheets, IPYNB notebook, so you practice it. Along the way, there's a homework assignments. And then I give you another homework assignment worksheets, okay, pattern sheets. So you can upload it and then code it within that, only within that IPYNB. The file name is HW3, HW4, HW5. You may be able to tell, oh, this is a homework. And then that you need to submit. All right, I believe this is it. Good luck. See you later.